In this video, you are going to be working on solving radical equations. We have to think about these as equations, not just expressions anymore. When we did the expressions in the day before, we only looked at multiplying by forms of 1 as needed to cancel things out. Now we have equations, which means I can multiply by a form of 1, or I can multiply both sides by the same thing. Radical equations themselves is where you have a variable under your denominator, such as the square root of x plus 3 plus 5 equals 28. The x itself is actually under the radical, not x plus the square root of 3 equals 25. That's not a radical equation. That one's pretty simple to solve. It ends up being irrational. The top one is a little bit more difficult to solve. You actually have to do things to both sides to get rid of that radical. So I'm going to start off with the steps that we are going to use to solve radical equations. So initially, you are going to isolate the or a radical. There may be multiple radicals that you'll have to end up isolating along the way, but to start you need to isolate at least one of them. The next step that you're going to do is you're going to square, cube, etc. both sides of the equation. So if it's a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides. Then you're going to simplify. You're going to combine your like pieces together, and then you're going to keep looking. After you simplify, you have to ask yourself the question, are there still radicals? If there are still radicals, you go back up to step number 1, isolate a radical, keep going. If there are no radicals, you get to move forward and just solve the equation. It's going to be a regular equation. It may be linear, it may be quadratic, it may be cubic, etc. You have to solve it. Set it equal to 0. If it's squared or above, factor to solve. After you solve the equation, you need to check your solutions, possibly more than one, and discard extraneous. This is the long step to the process. There is no shortcut to determine whether or not you have an extraneous solution. So you have to take your original solutions and plug them into the original problem before you did any math to it, before you ended up going through and squaring, cubing, etc. to both sides. It has to go to your original one, because you will add in some non-real solutions, and I'll show you using our calculator why that's the case. And then the last step is to write the solution set. Whichever ones are true statements, write those in set notation. So we are going to go through and solve a basic radical equation. So to begin with, step number 1 says isolate the radical. So I need to get the square root of 24 minus 4x by itself. So when I do that, I'm going to subtract the 3 on both sides. So now I have x minus 3 equals the square root of 24 minus 4x. This is an equation. So one of my sides is now isolated. I have that radical isolated. So now I go into step 2. I square, cube, etc. both sides. Since this is a square root, there's no number inside the radical, means I'm squaring both sides. Both complete sides. Please take note, when you square over addition or subtraction, you have to expand it out. You have to FOIL it out. So this x minus 3 quantity squared is the same thing as x minus 3 times x minus 3. Physically FOIL that out. Hopefully at this point you've learned the shortcut for squaring, and if not, no big deal, just physically do it. I square the first term, I square the last term, I multiply the 2, and double. And the nice thing about the right-hand side is when I square the square root, I'm just left with what's under the radical, which is 24 minus 4x. Now I simplify. At this point, also look, there are no longer any radicals. So I'm going to be solving this equation. I'm going to be moving on to step 4. I don't have to go back up to step 1. Since I have a quadratic, thinking ahead, I'm going to have to set it equal to 0, factor it, and solve. So I'm going to subtract the 24 on both sides, and I'm going to add the 4x on both sides. So I have x squared minus 2x minus 15 equals 0. Go through and factor. X minus 5, x plus 3 equals 0. Therefore, x equals 5 and negative 3. Now it's the long work. I have to physically check my solutions. No shortcut. I have to check. So I'm going to check both 5 and negative 3. Just because one works doesn't mean the other one doesn't, or vice versa. They both could work, they both might not work. So when I plug in, I'm going to start with 5. So when I start by checking 5 in, 5 goes for my x, so 5 equals 3 plus the square root of 24 minus 4 times 5. So I get 5 equals 3 plus the square root of 4 because it's 24 minus 20. So yes, 5 equals 5. 5 is a solution. Now we check negative 3. So negative 3 equals 3 plus the square root of 24 minus 4 times negative 3. So does negative 3 equal 3 plus the square root, so that's negative 12 minus a negative plus, so 36. So does negative 3 equal 3 plus 6? Does negative 3 equal 9? No. Therefore, I just checked negative 3. Negative 3 is extraneous, so it's a set containing 5. And then we will put negative 3 in parentheses to show it looks like it works, but it doesn't actually work. So, one of them worked, one of them doesn't. Why is this the case? Why is there only one solution to this? Well, what we're going to actually look at is after I moved over this 3, when I subtracted the 3 on both sides, in my calculator, what I'm going to look at is what do each of those sides equal. Because what I ended up having was x minus 3 equals the square root of 24 minus 4x. The left-hand side is a linear. The right-hand side is a square root. So I need to figure out when do my two x values equal to each other. That's really what we're finding. So if I go to my graph, you can barely see it in there, but this is what the graph looks like. My top equation is the x minus 3, that's linear, and then the bottom equation is my square root. So going into my graph, that top curved one is your square root. So this is the square root piece of it. Here's my linear. Based on those two, they can only meet at one specific point, which means there is only one possible solution to this. However, what I actually did, going back here for a moment, in my second step, when I squared both sides, this is what I actually did to solve it. I had to square both sides. I'm going to put that into my calculator so we can see what that looks like. So now I'm going to put in on the left-hand side the quantity of x minus 3 squared, and the right-hand side I'm just going to put in that square with the square root. So when I go into my y equals, I turned off my top two. So I turned off this one and I turned off this one. So the two equations I'm working with is the left-hand side squared. What shape is that? Parabola. And then the other side is my right-hand side, which is squaring the square root, which means that's going away, which is going to be linear. So now when I look at this graph, I did have to putz a little bit with my table to make it fit. But now I have a nice linear with a quadratic, which means it crosses down there and somewhere up there. One of those values is extraneous. One of those values is true. So if I take a look back where I had solved this, I ended up finding the two values for x. I'm looking at x. X equaling negative 3 was extraneous. Negative 3. This point up top here, I'm going to erase. That's my extraneous value. That's my non-true solution. And the point that's down here, I'm erasing last. That's the true solution that works. Figuring that out by checking it. Now, of course, you could plug that into your calculator for a really quick check to go through the process. But I do want to see that you are physically trying to see which of your solutions does work with your physical check, making sure that you're including that piece in there. So that's where you're looking at some of your extraneous solutions. I started it initially with a square root, crossing with a linear. They will cross one time. And then I ended up with a quadratic, that U shape, and the linear, which those crossed twice. Next one. This one gets a little bit more difficult. So now I'm looking at two square roots. Last one I had only one square root. Now I have two square roots. The algebra behind this is the part that gets a little bit more difficult. The concept itself should hopefully still be just as straightforward as it was in the last one. So we're going to look at both of these. So now, first step, isolate a radical. It doesn't matter which radical you isolate, you just need to isolate one of them. I'm going to get rid of the one on the right-hand side because it's a subtraction. So when I add it to the other side, now I don't have to worry about a subtraction sign. So I'm going to just keep going with this problem. Hopefully you can kind of flip back and forth between your steps to see what you're doing. So I'm adding that over, which means I have the square root of x squared plus 3x plus 6 equaling 1 plus the square root of x squared plus 3x minus 1. So I have one radical isolated. Again, it doesn't matter which one you isolate, you just need to isolate one. Then you're going to square both sides. Both complete sides of a binomial on the right-hand side. Binomial in shape, I guess. So you're going to have to physically expand that out. You're going to need to FOIL that. Left-hand side is quite a bit easier. The square and the square root cancel. C of x squared plus 3x plus 6 equals. So now I have to expand this right side out. I like to do my shortcut, square my first term, square the last term, multiply the two, and double. If you do not see that, then just do it. 1 plus the square root of x squared plus 3x minus 1 times 1 plus the square root of x squared plus 3x minus 1. So foiling, first I get 1. Outside I get 1 times the square root of x squared plus 3x minus 1. Inside I get plus 1, so that's one of them, times the square root of x squared plus 3x minus 1. And the last term, don't expand it out in terms of multiplying what's underneath the radical. You have two of the same thing. You have x squared plus 3x minus 1 squared. You have two of the exact same thing, which means the square and the square root undo each other. So when I simplify this down, I have 1 plus, I have one of these and one of the same things. So 1 plus 1 is 2 square roots of x squared plus 3x minus 1. And then the last part, I square that square root, which gives me x squared plus 3x minus 1. I'm going to just do one more step and combine this together before I move it back into my problem. So x squared plus 3x, the 1 and the negative 1 cancel, plus 2 square roots of x squared plus 3x minus 1. So that's the quantity I'm going to bring over onto the other side. Okay, so now, extend this radical so it looks like it's over it. Now I have to look at what do my steps say really quick. I simplified it a little bit. Are there still radicals? Yes. I go back up to the top. So there is still a radical in here. Now the goal is to continue to get rid of a radical. You should get rid of at least a radical each time. If you start getting more radicals in, you're doing something wrong. Most likely it's at this step when you're squaring that. So now I have to isolate a radical. So I'm going to move over the x squared and the 3x. I'm going to leave the 2 and everything else over there. So I'm going to subtract the x squareds. Fortunately, those go away. Subtract the 3x's. Hey, those go away as well. So left-hand side, I'm left with 6. Right-hand side, 2 times the square root of x squared plus 3x minus 1. With the 2, it is attached by multiplication. So when I go through and square both sides, over multiplication, that 2 is going to be squared as well. So it's going to be 4 times that quantity. The nice thing is I only have a 6 on the left-hand side, which means I can actually divide both sides by 2, and that's going to give me 3 equals, and then this quantity. That's not always going to happen. You are sometimes going to have a fraction. There's going to be multiple things on the left-hand side. It gets ugly. So I'm going to go through as if I couldn't do that. Because I can, it really simplifies the problem. But if I couldn't, that's how I'm going to kind of continue on so you can see what's going to happen when you're working on problems where it doesn't break down. So because I have my radical isolated, what's attached to it is only by multiplication, which is an easy fix. So I'm going to square both sides. Because this is multiplication, I square the 2 and I square the other quantity, which means my radical goes away. and that of course equals 36. Then at this point you could again divide through, get rid of that 4, the 2 squared which is 4, divide both sides by that 4 to get rid of it. The other thing you could do is it is attached to this entire quantity. I could expand it through, whatever is easiest. At this time, just to make our work a little bit easier, I'm going to divide both sides by that 4, which gives me 9 equals x squared plus 3x minus 1. It's a quadratic, which means I have to set it equal to 0 and factor. So 0 equals x squared plus 3x minus 10. Factoring gives me x plus 5 and x minus 2. Therefore, x equals negative 5 and x equals positive 2. Lastly, check. Got to check back in your original problem. So I'm going to check negative 5 to begin with. So when I check negative 5, this again takes a little bit of work along the way, plugging it back in to this initial equation here. So it's the square root of 25 minus 15 plus 6 minus the square root of 25 minus 15 minus 1. That's supposed to equal 1. So therefore 4 minus 3, does that equal 1? Yes, it does. So negative 5 is a solution. Now I have to check 2. So when I check 2, do the square root of 4 plus 6 minus the square root of 4 plus 6 minus 1. I need to see if that equals 1. So I get 4 minus 3 equals 1. Yes, it does. So 2 is also a solution. Be careful here. Make sure the value that you're putting inside of your set notation is the one you checked. 1 equals 1 was the true statement. The value you checked is 2, which is why 2 is what goes inside your set notation. So as you go through these, when you're isolating your radical, be really careful when you're going through and expanding, specifically in a problem like this. Make sure you physically FOIL it through. If you shortcut it, square the first term, square the last term, multiply the 2 and double, that will work as well. Just keep in mind if you're not the most consistent with that, you may need to do a little extra practice, pull it outside the problem, and then always bring it back in. There's nothing wrong with bringing it back into your problem, and then of course your final answer is in set notation.